This is the solution video for problem number 7 from 1.7. All right, so the directions say in 5 through 8, use the limit as h approaches 0 of f of a plus h minus f of a over h to find the slope of the tangent line to each curve at x equals a. All right, so we're going to use the limit as h approaches 0 of f of a plus h. So f of x is 1 over x. So f of a plus h is 1 over a plus h. But in this problem, it just says use x equals a. So a plus h minus f of a. So remember, f of x is 1 over x. So f of a is 1 over a, all divided by h. So now we want to evaluate this limit. So first step in a limit, of course, is to evaluate. So I would have 1 over a plus 0 minus 1 over a over 0. So 1 over a minus 1 over a is 0 over 0. So, of course, we have more work to do. All right, so what we want to do is we want to get these two fractions together so that I can get this h to reduce. So how do I get the fractions together? I am going to multiply each fraction by the other denominator. So on the side here, how would you take 1/2 minus 1/3, right? That's the strategy that we want to use to add these together, all right? We cannot simply add h to this fraction because that is mathematically unacceptable, okay? Why is that? Well, think about this. If I have 1/2 minus 1/3, can I just add 1 to this and say, oh, now this is 2/3 minus 1/3? Definitely not. So the strategy here, how would you take 1/2 minus 1/3? You're going to multiply this fraction by 3 over 3 and this fraction by 2 over 2, right? So same thing goes here. We're going to take the 1 over a plus h and we're going to multiply it by a over a. Minus, we're going to take the 1 over a and we're going to multiply it by a plus h over a plus h. That's an a, all divided by h. All right, so now we're going to simplify the numerator a little bit. Limit as h approaches 0. All right, so this becomes a times, or sorry, divided by a times a plus h. Minus, this becomes a plus h over a times a plus h. And then all divided by h. So now I have a common denominator in the numerator, so I can get those together. So I have the limit as h approaches 0 of a minus. Now remember, this minus goes to that whole fraction, so we have to distribute the minus to the a plus h divided by a times a plus h. Now, I also have this divided by h. And a lot of times people forget about this. If I'm dividing by h, isn't that actually the same as multiplying by 1 over h? So then I can take that h, and if I multiply this by 1 over h, then I really just have this next fraction times 1 over h, which means that I really just have an h multiplied in that denominator. So the limit as h approaches 0 of, all right, if I distribute there, I get a minus h divided by a times h times a plus h. So now let's subtract a minus a. So now I'm left with negative h. So the limit as h approaches 0 of negative h over a h times a plus h. Now, think back all the way to the beginning. What needed to happen? H needed to reduce. So now it does. And so we have the limit as h approaches 0 of negative 1 over a times a plus h. And so we would reevaluate. So we substitute 0 in for h. So I get negative 1 over a times a plus 0, which means negative 1 over a times a, or a squared. So negative 1 over a squared.